Milling by Jacob Triglia. The history of the chemical milling. Chemical milling started in 400 BCE when they were using vinegar and salt to etch into lead that would make nowadays called white lead. It was also used in the Renaissance period for soldiers' armor. You can see in this bottom left picture here, it's the etched image. They would use it to make ornate patterns and stuff on their armor, which made them look higher in class. Today, it's more usually used in the aerospace industry. You can see right here, this is a diagram of a side panel of a missile. You can see these areas right here in the lighter blue, or what was etched out, in the darker blue where the mass would have been put. This makes them more aerodynamic and takes some of the heavy material off the panel, so they're less in weight and fly better. Third image right here, you can see is a circuit board. You can see where the mass were put and where it carved it out to make this circuit panel. Steps in chemical milling. First is residual stress removal, which is previous manufacturing processes may have put stress on it, which we have to remove those before we put them in the bath of the etching. If not, it'll create warps. Surface preparation, you can see in this image, is just degreasing and getting all the stuff off the surface, because you need the adhesion of the masking to stick to the metal. Masking, you can see in this picture, the green is the mask, so that area will not be etched out. The gray area will be etched from the acid. Fourth is etching. You can see right here, they're dipping this metal part into this bath, and that will be how it's etched. And demasking is just the cleaning and taking of the masking off after you're done with the process. Pros of chemical milling: lower cost, so you don't need to buy dyes and other special jigging for the process, so it costs less to start up. No additional machining needed. Down here in the left corner is you can see this is burrs from conventional milling. With chemical milling, there's no burrs, so there's no other machining processes needed to clean the material off. So this in turns cuts half the time and cost compared to conventional milling, because after conventional milling you need to ship it to other machining processes to clean it up. Initial quantities of newly designed parts can be ready in hours, so it's a quick process. Application of chemical milling today, you can see here some images. This is aviation pieces. I put these two images are from some part of an airplane. You can see where exactly actually this was chemically milled out and where the masks were put. Up here is just another circuit board, an example of an application of chemical milling today, and then another picture of a side panel of a missile. Equation for etch rate is what you use to figure out the surface that will be removed during the etching. You can see equals S divided by T. S is the depth of metal removed per surface per mils. T is the time required to remove S metal minutes. And this is it for my presentation of chemical milling. Thank you.